Okay, we're going to be discussing quadratic functions. So there's actually three forms that a quadratic function can come in. The three forms are factored form, standard form, and vertex form. So looking at this graph, the simplest form, when you're going from a graph, usually the simplest form is usually to do the vertex form. The vertex form, we just need to find out the vertex, so that's going to be at -3, -2. So we have a vertex of -3, -2. We can go ahead and write that in right over here, actually. Actually, let's find all the key features, and then we'll go ahead and write it in these three formats, okay? So first of all, this parabola is opening up. If we put arrows on the ends here, the arrows kind of tell us which direction this parabola is opening. It's opening up. Therefore, the a value, now remember the a value in standard form, that's that leading coefficient. Okay? Vertex form, same thing. It's in the front. And then in factored form, the a value is also in the front. We'll talk about these forms in a few moments, what everything means. Okay, so the a value, since this is pointing up, the a value is going to be a positive point. It's going to be okay, it's going to be positive. The a value in all of these forms is going to be positive if it is opening up. All right, so the line of symmetry. The line of symmetry is going to be that line that splits this graph into two equal pieces. So if we draw a vertical line, and it is always going to be a vertical line for these types of graphs. And to write this equation, vertical lines have an undefined slope, and they always start with x. So x equals -1, -2, -3. So our line of symmetry is x equals -3. That's the only kind of line that ever starts with an x, is lines that are vertical. Okay, y-intercept. Well, in this case, you can't see it because it's where it crosses the y-axis. So let's come back to this one later, okay? I will tell you that the c value in standard form is going to be the y-intercept, okay? So I'm going to put a little c over here just to remind us that that's going to be the y-intercept. The x-intercepts, that's where it crosses the x-axis, so it crosses at -2. And it crosses at -4. These are also known as the roots. That's very important to know because we're going to be using these two numbers here, the roots, when we write factored form. Okay, so let's next write this equation in vertex form. So first, we need these three numbers, A, H, and K. And we actually already have H and K. H and K represent the vertex. And we know the vertex is -3 and -2. So we already know those two numbers. What we don't know is the A value. So to calculate the A value, you're going to go to the vertex. And to calculate the A value, you would go over just one unit. You can either go left or you can go right. Okay? And then the second thing you do is you count up or down, depending on which way the graph goes. The graph is going up, so you're going to count up. So 1, 2, and as soon as you touch the graph, as soon as you touch the parabola, you have then counted the A value. So +1, +2. So the A value is going to be 2. So now let's plug these values in. So we're going to have 2 parentheses x minus h. H is -3 squared plus k. K is -2. So the way we want to simplify this now so we don't have all these parentheses is it's going to be y equals 2 parentheses x. 2 negatives make a positive. And when we add a negative, it's the same as subtracting. And so there is your vertex form. Okay, factored form. So a factored form, we need the A value. We already calculated it. We need the 2 roots, and we know those as well. Here's root 1, here's root 2. So root 1 is going to be -2, and root 2 is going to be -4. And it doesn't matter. You could put -4 here and -2 here. It doesn't matter. Okay, so let's write factored form. So it's going to be y equals 2 x minus -2 is +2 x minus -4 is going to be +4. Remember, when you subtract a negative, it's the same as adding. Okay, so let's go to standard form. Standard form, we know what A is. A is 2. But we don't know C and we don't know B. So what we're going to have to do here is we're going to have to do some manipulating. So I'm going to go ahead and manipulate this form right here. So 2 times x plus 2 times x plus 4. So first thing we're going to do is we're going to just multiply these two together. So we're going to distribute. So we get 2x plus 4. Keep it in parentheses, because now we're going to multiply that times x plus 4. Now I'm not sure how your teacher taught you this, but a lot of students like to use this little graphic organizer called the box method. And some students like to do FOIL method. So 2x plus 4 goes on one of the sides, and then x plus 4 goes on the other. Filling in the boxes, we're multiplying. So 2x times x times 4 times 2x is 8x, and 4 times 4 is 16. All right, now we're ready to write it in standard form. So here is your x squared term. Combine like terms, 8x plus 4x is 12x plus 16. Guess what we know now? We know the y-intercept. And we write this as a point because the y-intercept is a point. And 0, 16 would be way up here somewhere. Okay, domain. We've already learned this, but I know some of you struggle with domain and range, so we'll do this really quick. Domain left to right, arrow on the left, arrow on the right. So left infinitely, right infinitely. range, lowest to highest. So lowest is going to be at -2. If you count down, it's a closed dot, so it needs an equal sign. Highest is an arrow. All right. Now, I'm not going to go through this example so much, except to say that if you put arrows on this, that means your A value is going to be negative. If you want me to do another video on this example, please send me a message. I will do this example for you and post it in Google Classroom for you. Just let me know, okay? So now, let's talk about this, since we do have some time. Let's talk about vertex form. So, vertex form. If there is a negative sign in front, this means the graph reflects over x-axis. Or you could say opens down. Okay, that's if there is a negative sign. So what happens to the graph? Well, that's if there's a negative sign, but let's talk about this number. So if A is greater than 1, then the graph is stretched vertically. Kind of like this. Kind of looks kind of narrow. Okay? If A is greater than 0 but less than 1, like 0.2, 1/2, 1/4, then vertically compressed. So it's going to kind of look wider. All right, what happens to the graph here? Well, H, this, I always tell my students, this is always going to be this is a translation. If it's minus, it's going to go to the right, and if it's plus, it's going to go to the left. It's going to be translated. So if it is x minus h, then translated right h units. X plus h, translated left h units. It's the opposite of what you think, okay? All right, and then k is going to be up and down. So if k is positive, so if it's plus k, then it's translated k units up. If k is negative, translated k units down. Now, since I have a couple seconds left, the thing I want to say about A is when you're determining stretch and compression, do not look at the sign. Okay? The sign tells you if it's going to open down or if it's going to open up. If it is positive, if A is positive, it's going to open up. If A is negative, it's going to open down. But when you're determining stretch and compression, do not look at the sign, okay? It's kind of like this. You want to cover that sign up and only look at the number. If it's a 2, it's stretched. If it's a half, it's compressed. Thanks, guys.